Welcome back everyone. Now we are going to look into an example, manual example where we will try to get out the clusters out of it. Okay, we have already looked into the algorithm. Okay, we have these 7 steps, majorly 6 steps, and after this third and fourth one, we check around if we are getting exactly what we need. If it's okay, then we move to step 7, and or else from step 5 we will again move back to step 6 as step 3, and continuously we are going to until we get the best fitting model. Okay, that is what we mean when we say that it is an iterative algorithm. Okay, so let's start. So at the first iteration, what was the first step? We have to select the number of k, and we have to and step 2 is select k points or centroids. Okay, in the input data set. So we have this input data set, we have this data set at iteration 1, that is at step number 1. What I've taken is k equal to 3. Okay, now we will look into a way to how to get good value of k. Okay, right now it's like very much on our choice, it's based on our choice, but there are some techniques by which we can find out what should be the best k value. Okay, as of now let's take k equals to 3. But yeah, in our next video we are going to learn about a method by which we are going to know about what should be the probable or a nice value of k. Okay, so we have this first step, we have randomly take 3 k values. Okay, three uh, 3 clusters, and then in the next step I plotted out into the input graph. The third step was to assign data points to their closest centroid, which will form the predefined k clusters. Okay, so what we are going to do is we will assign each of the data point using this scatter plot to the closest k point or the centroid. Okay, for this we are going to use some high school maths, high school geometry, which will help us to calculate the distance between 2 points. Okay, so what we are going to do is we are going to draw a median between both the centroids. Okay, all of the 3 centroids. So we have something like this. Let's say this one is this. Okay, and from this we have the value as this. So we can say a straight line somewhere over here, a straight line over here, and a straight line over here. Assign this as a straight line. Sorry for my bad drawing, but so whatever we have upside of this, okay, this one, this line is is with the blue cluster, is belongs to the blue cluster, and whatever we have in the red one, red zone, is belonging to the red cluster, and the green one, whatever we have below this line, this specific line, it's all belonging to the green cluster. Okay, then in iteration 2 we have something like this. Okay, that is on iteration number 2. Again, we move into the third iteration. Okay, now all my data points look something like this when we have plotted it out. In the third iteration, what I am going to do, again I am going to do the same step. Okay, as you see that our clusters, okay, where was our clusters? Our clusters were over here, and they shifted out. Okay, as all of these points belong to different groups, so my cluster, the red cluster, will be moving to the area which is somewhere like over here. The green one might something over here, and the blue one will be probably over here only, it will move to a bit. Okay, and then we have uh, our clusters like this. Again we will try to do the same thing, we will find out the distances and find out the line. Okay, the best fitting line, the line, and from, okay, this line, and we have this line, and then we are going to do the same thing. Whatever we have over here, all of these points will turn into blue, and after turning all of these blue, what we will do is we will move the clusters to the dense area. Okay, so that is somewhere over here, this will move over here. The red one also something like that, and the green one also something like that, it will move over here. Okay, so if I move into the third iteration, we get something like this. Okay, it moves around the places. So that's a repetitive process, and it's going to go on until we are at a point where there is no variance. Again, at iteration number 6, see, at iteration number 3 we are having something like this, At iteration 6, again this x has moved a bit over here. That is, let's jump into 3 more iterations and we will be getting something like this. Okay, so here is our final figure and it is totally converged. As you see that if we plot a straight line also, if we find out the distance, we will be having a line something like this for this. Okay, again for the green one also, if we do, then we will be getting a line something like this. Okay, so as you see, these are in iteration. If you try to do one more iteration also, it will not move any place where, because it is in a place which is like quite the average distance from all of these. That's the inertia. Okay, the variance part. Again, for same for the green and same for the blue. So this is my converged. This is known as my converged data. Okay, converged data points. So we get something like this. So that's how manually it went off, and that's all about k-means algorithm. If you see this figure, okay, over here, if I do again the same thing, we have 2 points, we might have 2 clusters, and from those clusters I will again try to find out, okay, what are the points we have. After getting out the points, we might see that it might shift over here, this might shift over here. Again, we find out the distance between these two. Again, we find out that this will shift somewhere place over here, and this shall move somewhere place over here. After this, this is the converge one. Okay, I know the figure looks very dirty, but let me show you the final figure. Okay, so from these and these, it moved to here, and then might over here, then it might move over here, then this might over here. So finally we get something like this. So we have two figures where k, the value of k is equal to 2. These black points are my cluster centroids, and all the different color seeing that it belongs to a different clusters of. If you want to have a visual implementation, that's how it goes on. Over here we have the iteration. Okay, after each and every iteration, how it belongs. See, at iteration number 1 it was very much randomized, and after each and every iteration it is getting a more better and better fit. After 9 and 10, when we were at close by, after at 8 and 8 to 10, you see there were not much changes. See, after 9 and 10 both were having the same thing. So that's the end point, and that's where our model gets converged. Okay, so that's about everything for k-means algorithm. In our next video, we are going to look into a method by which we can find out the correct value of k. And we are also going to look into what can happen if we don't have the exact or the right value of k.